Hi, everyone. Welcome with our next episode of Lost in a Light Field. Today, I want to introduce our guest, Renee Schulte. Renee Schulte is a prominent technology leader, innovation expert, and thought leader specializing in emerging technologies such as artificial intelligence, spatial computing, and extended reality. With extensive experience in software engineering and technical innovation strategy, Renee has worked in various leadership roles at Reply. He's a recognized Microsoft Regional Director and most valuable professional with the short abbreviation MVP. Welcome, Renee. Great to have you.
Yeah. Well, thanks for having me, Saskia and Alex. Great to see you again, and always happy to have a chat with you. So, what are we going to talk about?
So we're so happy that you're here. Our topic today, as you know, is the future of AI, key trends shaping tomorrow. And if I understand correctly, you're going to tell us about three really interesting trends that are happening, which is multimodal agentic systems, and then synthetic data, and also embodied intelligence. So that's a lot of words. I would say let's dive right in with our first question. What are multimodal agentic systems and how are they different from traditional AI models?
Yeah, a good question. For sure. Let's explain first of all what are we talking about when we talk about multimodality, and then what is the agentic systems. So basically, when we talk about multimodality, it's the next evolution of language models. In the end, that's mainly being talked about when we think about multimodal models. And you might know the abbreviation LLMs, like large language models. And the next one is LMMs, so large multimodal models. And multimodality basically means that these models can not only understand different types of data, different modalities, but also generate different modalities. So think about not only text in, text out, but vision was one of the first things that was added with GPT Vision, for example, with GPT-4. So you can give an image and ask what is in the image, right? And then you get a textual response. So image plus text prompt in and text out, right? So that was first form. Then, we saw extensions with video, with vision. We have now real-time vision from Google Gemini Live, really deployed into commercial products, but also OpenAI, also Microsoft, or, providing these kind of functionalities. So in the end, multimodality means, and a true multimodal is a model that has not only various models chained together, because that is what some are using, right? When you give it an image and then they use a language model, a vision model, to then computer vision model to describe what is in the scene, and then they feed it into a large language model. This is not what I'm talking about. I'm talking about true multimodal models. They are trained with so-called joint embeddings, meaning when they train with the text, they also train with the matching audio token, right, for example. And so this is then joint embedding in the neural network in the end. And so that's also how this real-time audio actually works so well, because they don't need to go from speech to text and then do the text processing and then go to text to speech, but they can do it all in one shot, right? The model actually produces the audio data already. And that's what we're talking about, multimodality. And basically all the big models, the large foundation models, support at least vision these days, but most of them also, the good ones, audio. Video is also there, slowly coming, and some of the work you're seeing is when you can share a screen with such a system, right? When we talk about agents, we should also be a little bit clear there. What are we talking about? Because the whole thing when we talk about agents, it's everything and nothing, right? It feels like, for me and for you, my friends, you might remember also from the whole extended reality. What is mixed reality? These kind of various vague definitions. Still everyone is probably having their own definition. The same thing is actually with agentic AI. But we can basically go from a simple chat experience, like you might use when you use ChatGPT or Microsoft Copilot. We can then go to more of an single agent system, where basically you instruct that language model. Usually it's a language model that is behind that agent, but it could be any AI model, right? It doesn't also have to be an AI model, right? An agent is basically the role. And when you have a single agent, you give that model specific instructions and a kind of a role, and you define also the context and give it some kind of a little bit more autonomy, right? You can connect it to that it can call APIs and do kind of things. And the next level is then multi-agent systems, where we not have one agent but multiple agent. One example could be software development lifecycle management, right? You have an agent that would play the role of your PM, or let's say business analyst first, right? That extracts the requirements and provides proper information to the developer agent, which then writes the code. And then you have the QA agent, which does the testing, checks all of this. And in the end, you might also have an agent that manages all the life cycle and so on. And they all work in a tandem, basically. And you as a human orchestrate a group, a team of agents in the end. That's what's going to happen also when we think a lot of the fields out there, like software development and so on. And then the next stage of that, you can even make it further, is agentic, not only multi-agent system, but an agent society. Because what we're having now, Microsoft has their multi-agent system, right? Google has their multi-agent system. All of the big hyperscalers have kind of an agentic multi-agent system. And so if you want to, connect those and work together, this is why we have this agent society, where we have these various heterogeneous agentic systems, but they need to work together. And one thing to do is the Google A2A, the agent to agent protocol, for example, right? But anyhow, I'm
just
all going
wondering.
to become managers of just a pool of agents in the future instead of developers. Sorry, Alexander.
Yeah, it's like working with a group of digital people who are doing for you.
Yes.
I think just because I know a lot of the listeners will be like, yeah, but I still don't understand what an agent then is.
Yeah.
I mean, can you, for example, compare to doing a workflow? Because if we're running a workflow, you could say that's also which is sending out tasks and executing it. But an agent is different. Could you show an example of that, or explain an example of that, what the difference would be?
Absolutely. And like Saskia was saying, right, it's really like you're becoming a manager of agents, and you're orchestrating a bunch of agents. And before I answer your question, Alex, another example which is really nice is the GitHub Copilot agent that was just launched. And I still have a good old open source project, which I try to keep on maintaining, but since lack of time, I wasn't able to fix any of the issues people were logging, right? And so shame on me, but anyhow, that's just how it goes sometimes. But anyhow, what's pretty cool about it, I tried GitHub Copilot agent with one of the issues a person logged on my writable bitmap X library. And you have to know the issue was quite complex. The person had issues when that, it's basic image processing library, and you can draw a line with anti-aliasing and all low-level stuff. And the person had an issue with a certain angle. It wasn't anti-alias, whatever. And so the cool part is with the GitHub Copilot agent integration is, I go to the issue on GitHub, and you probably have, if you used it, you see the list of assignee, right? You can assign this issue to a person to then fix it. Well, now I can assign it to GitHub Copilot agent. And so I simply assign it, and then it starts to do its work. It's really impressive. It comments, oh, I'm going to start on this, and then I will come back to you once I have it fixed. And I checked it 27 minutes. It took it 27 minutes, and then it actually came back with a pull request. Much better documentation than any human would write, right? It's like, hey, here's the issue identified, here's the fix, and describes it all very well. And then as a human, assigns it back to me to review the PR, and then potentially merge it in. But this part is really amazing because you have this autonomy, right? And the other aspect is really the integration into GitHub. I think that is super powerful, in fact, because we have these the tight integration is really a big enabler, I think. And also you can choose which model it's going to use behind the scenes. So that's cool. And that's also answering a little bit of your question, Alex. It's one important aspect is the autonomy. So you give this agent a task, and then it basically starts to work on it and comes back to you when it has a result. And another big difference is, of course, you already alluded to, if you look at, of course, you could do like workflows, like certain processes. But the big difference between it is like, let's say, between an RPA bot, for example, you have, first of all, more deterministic control of an RPA bot, and your agentic system running with language model is more non-deterministic, right? These are all probabilistic models behind it. And of course, we can use RAG or other patterns to improve more the outcome. I would say that that's more in a certain range, but in the end, it's still probabilistic models, right? Each time you run it, you might get a slightly different result. And that's one thing people need to keep in mind is, of course, you need to check the results in the end. But the most important aspect is the complexity. The more agent you add, of course, it gets more complex, but the human effort also gets reduced and so on. And the autonomy is increasing. And like Saskia was saying, in the end, we're basically a PM, and developers will become actually more technical program managers and that orchestrate a bunch of agents.
I actually have a follow-up question. Sorry, Saskia. I want to ask this one because Renee is triggering me something. So when you have a group of people working for you, doing the work, and then going back to you to validate, people make mistakes. So compare it to agents, it's a bit similar. They doing it on their own. They can make mistakes. Hopefully they don't. The thing is, when you have a group of people working for you, they actually learn from their mistakes. Now, the thing is, how does that work with agents? Are they also learning from their mistakes and doing the next step better? Or are they still based on the grounding they are, the data they are grounded on? And are they still making the same mistake? Does that make sense? Because you want to have a learning system if you talk about collaboration.
It makes a ton of sense, of course. Very valid question. And exactly like you're saying, right? The problem is, like, if you're not using a memory, that's what you probably have to do. It's like integrating a memory layer. There's also libraries that help you to do this with your agentic system, right? And basically, you would like, add this to the memory. And we also see this in consumer-facing language models like ChatGPT and all the other ones. They also have this kind of memorization now. Of course, you can clear it, but yeah, that's a very important aspect of your multi-agent system, right? It's a very good point. Basically, on the stack, you have also definitely the memory as part of that, and that's important that they learn from the mistakes or the corrections that were made, right? So what you have in the end is when you have these agentic system from the stack standpoint. First of all, on the lowest stack, you have the AI infrastructure, and then on top of that, you have all the data, right? The data hubs, if you will. Then you have your foundational models. On top of that, you have agentic factories. And then, you can also, on top of that, you can have very specialized agentic copilot tools, for example, that are fine-tuned for specific target scenarios. And then you can have those interacting with each other, and they can also access external application thanks to this MCP protocol, right? Where they can then autonomously control an application or have some data from there. But the memory aspect is definitely an important thing that is a core piece actually of an agentic factory, right? That you not can only orchestrate multiple agents, but you can also keep memory in the state. And that's important for sure.
That would make sense. Yeah.
Maybe could you also have like other agents that do the testing? Like or the error checking?
Yeah, definitely. We have actually a new offering called Silicon Shoring. And this is redefining software development with multi-agent solutions. And part of that is a bunch of agents. It's like over 40 agents or so. And we also have security agents that check for security vulnerabilities. You have QA agents, and they have kind of a loop, right? They kind of iterate until you reach a certain threshold. And that's what you do, right? You set a goal, basically, with your multi-agent system. This is when you're done. Like, we reach this level, then you're done, right? Because otherwise, it will never end.
Yeah, they will continue.
Right? That's what you need to set. You need to have, basically, if your process, like, just think about the work process, right? You also need to set clear goals with a team of people you're working with, right? If you don't do this, nothing will happen ever. Like, it's just spinning in circles, right? And this is the same for the agentic systems.
Yeah. So basically, if you're a software developer now, building those kinds of agent systems sounds like a completely different skill set. Like, what do you think are the challenges or the skills that developers would need now to build those kinds of systems? Like, what are the challenges? And like, can you just vibe code all of that? Or is it like a new skill set that you need to learn to be able to do this?
Yeah, it's a very good question. And definitely there's a little bit of a mind shift we have to do. And especially like if you have been doing software development since many years, it's definitely something to change your mind a little bit. Because in instead of having to write every line of code, you basically use an assistant that helps you to write every line of code, and you just give the bigger picture basically. And the skills that are needed for this is still a very good analytical mindset. And what might shift a little bit more is you are the bridge between the client, the humans, and the agents, basically, right? So you need to translate the client requirements into good prompts in the end, and good requirements, because otherwise, bad stuff in, bad stuff out, right? It's going to happen. It's the case all over, right?
So you're
Are there
actually
already
saying that everyone needs to become a prompt engineer. That's our new role.
prompt engineer, tech lead, manager? But like,
Yeah.
are there already like say online courses on like that teach you those kinds of skills that say, no, I want to learn all of this. Where would you recommend people start?
Yeah. I would definitely say, deeplearning.ai is a good one. So I would recommend to check out deeplearning.ai. It's Andrew Ng, very famous figure in the world of AI. So definitely check this out. I would start there. Also, Microsoft has a bunch of good, learning, how they call it, like the tutorials, basically. The learning. You guys help me. What's the Microsoft Learn thing?
So
Like
learn.
the courses, basically. Microsoft Learn.
Learn.microsoft.com nowadays.
Exactly.
I'm thinking. I know because we're going to do less and less coding for development because we're going to have agents, but you still have to build the agents. Now I know I'm from the Microsoft stack, so I'm mostly focused on that stuff. So now with Copilot Studio, you can create agents without writing any line of code, but still your agents need to perform certain tasks. So you need to write some type of skills libraries which allows you to connect to different systems. Now there are already a few available, but as soon as you want to, for example, connect to your own data in your organization or specific systems, or you need to have different results, you need to write them yourself. I think that's now what they call MCP at the moment. That's the MCP part, if I'm right. So I get a feeling that while you're doing less development as a developer, you have to optimize your skills, but it's also shifting to a different spectrum what you're going to do and what you're going to build. So it's going to be partly functional, partly technical, with support of a agent.
Yeah.
Does that make sense? Is that the right direction?
Yeah, that definitely. But I wouldn't say you're going to do. Maybe let's rephrase that. You're not going to do less development. You're doing less boilerplate coding, right?
Yeah,
That's
that's a
maybe
good one.
the better way to express it, because it's still being developed, right? Like, but you're not going to write every line of code, and that's of course it's basically iteration of IntelliSense, right? We got with GitHub Copilot, then we have GitHub Copilot Chat that worked on a higher level on the whole file basically, and now the coding agent that even has the whole project view, if you will. And so that's going to evolve, and the skills are still very much relevant. That's also what I keep on telling students that are worried. It's like, the skills are still very much needed, because you need to understand what's going to happen behind the scene. You need to understand what, how these things work under the hood. This is the only way how you can do it properly, right? It's also when you do computer graphics, right? I know we're all computer graphics people originally, and you got to understand the hardware a little bit, because otherwise you write code that is not optimized for it and will just run very slow. And the same in particular, sorry, let me just finish that thought. The same in particular, I'm getting more and more worried is with the vibe coding, the whole vibe coding. I mean, I also use it, right? It's amazing. It's great for some cool, nice projects. But what I'm a little bit worried about is that lots of folks that have no technical background at all do this and then publish these solutions. And we just heard about Lovable and Superbase, right? Exposing massive data, basically. So it's completely unsecure backend. And
I'm going to say that one.
and I mean, what I expect the next couple, and then also think about how these these models are trained. They're all trained pretty much on open source code, on public code basis. And in some of these code bases, for sure, there are security vulnerabilities that are unknown, that are going to be detected, let's say, in a few months or a few years, right? They're going to find an exploit somewhere. And now imagine all of this is developed and implemented into all these vibe coded solutions. No one cares, because vibe coding is about you just type, you don't care what the code is. I don't care. It's just like, poof, works, and okay, great. And then I deploy it to the masses, and then poof, at a certain point, it's going to fall down, and there will be a massive security issue in the next couple of years for sure. At the
Yeah,
same time, you might also argue at the same time, well, there will be agentic systems that constantly check for these security vulnerabilities and will probably be faster than a human to address these bugs and fix those. That could likely also happen, but at the same time, I'm pretty sure the vibe coding, as great as it is, we still need people that have a technical background to understand and also fix things when they're broken. Because easy stuff is quickly done with vibe coding. If you do more complex things, you definitely need a good architecture background. And so for developer, architecture, very important skill for sure.
Yeah, I've noticed when I was building something for Unity and I needed to support, so I used GitHub Copilot, asking, can you create some code? And then the first thing I was like, oh, let's just copy the code. Don't change anything. Don't look at it. Just copy. See what happens. So it didn't work that well. I was asking for a way of zooming into an object, and it needs to go over all the 3 axes. And funny enough was instead, so normally what you would do is asking, give me the code, and then you can start, and then you just copy paste. But I was like, now let's narrate together with the LLM or possibly in the agent together in, I'm seeing this. Can you help to fix that? And that collaboration suddenly within a few attempts, I think within 4 or 5 attempts, we got the code right. And the funny thing is, if I look at the time I only spent 10, 15 minutes. If I had to write it myself, based on maybe some code examples, I would be probably 1 or 2 hours. Yeah. That's just amazing. So the way of collaborating, not taking everything for granted. Yeah. And then in what you're saying, you still need to have the knowledge, knowing how something needs to work or where the problem could be. And this is just purely a way of how you visualize something. Again, what you said, when you have not security implemented, the problems you can get when you're going to start building this stuff for larger enterprise organizations is going to be terrible. So it is an interesting future we're going to go into with agents and with LLMs.
Will we still be able to actually understand the code? That's my question, actually.
Yeah, that's a good one.
Think about it. Like, have you seen, there was an example where we had 2, like the real-time conversation agents, right? The real-time, like chat GPT and others have this, the real-time audio conversation. And there was an example where they had like, it's 2 smartphones or whatever, like 2 of these agents talk with each other. And at a certain point, I think it was a Google demo or whatever, they invented a new language because they could basically communicate much faster. And so, we as humans couldn't understand, but these 2 as AI were much more efficient in talking with each other. And that's probably also going to happen with agentic systems when they have to communicate with each other, but also think about writing code. Why don't they just simply invent a new programming language? Because the coding languages, the higher level programming language, they were invented for us humans to understand them, right? I'm not sure. I still have done a little bit of assembler, right? And so we started from machine code to assembler, then high-level programming language, C, C++, and so on, all the further that came, and then scripting and so on. Well, maybe they go a little bit back because they can understand it all,
right? They can make it easier to make it just short.
Efficient. Yeah, they just program an assembler. Then you have an agent that explains to you what the code is doing.
Exactly. You have then the translator agent, right? So that's definitely an interesting thought, I think. So yeah, not sure. We'll see. It's an interesting future for sure. And just make sure you leverage good security principles. I think that's important.
That's a good point. Yeah.
Shall we move to the next subject?
Yes, let's move, because we have 3 topics, right? And your second topic was synthetic data. So what is synthetic data? How do you generate synthetic data? And why is it so important in regards to AI, René?
Yeah, very, very good question. You guys are asking the best questions. But in all seriousness, when we think about AI these days, I was surprised actually a couple of months ago. I heard an interview with some experts from OpenAI, and basically they said they're not so much compute bound anymore. So they're not so much limited on computing power anymore. They have plenty of graphics card, and it's still kind of a little bit bottleneck, but it's not the limitation. What they said is the biggest limitation for them right now is the data scarcity. They're more data bound. And that's what you hear from all the big foundational labs, actually, that we're slowly reaching a point where they basically digested all the data, the public data they can get the hands on to train these language models. And so now they're trying to tap into very specific non-public data sets to actually get access to. And, of course, you're also reaching a limitation there. So, of course, one of the solutions is to actually generate synthetically training data. And that's what synthetic data is all about. You generate training data for a machine learning model, and that is not available with real-world data. What you can also do is you can augment real-world data. So we're running a project, for example, where we're dealing with patient information, very highly, for us in Europe, very highly secured, personal private information. And of course, you don't want to, give all the data to a system to then train it. And so instead, you want to anonymize it. But if you do this too rigorously, you will lose a lot of good correlations. And so there's a good methodologies where you can still anonymize it and then actually take the data you have and then expand this, get augmentation of the data, make the data set bigger. And what we saw there, of course, if we then train a machine learning model with that, we get much better variance, much better generalization of the outcome. And that's a beautiful benefit. And so that's just from the classic machine learning world, right, where we can use synthetic data. And in fact, if you look at Microsoft V4, one of their smaller language models, that was also massively, or Google Gemma, they also said a lot of that is actually also trained with synthetic data. So we're also reaching a point where we use another language model to generate data to then train a smaller language model and so on, right? That's also known knowledge distillation, where you take a big training model, extract data, and put it into student model, which is much smaller, but is for specific use cases. So that's when we talk about, like, I would say, structured data, or actually unstructured data as well. It's simply text. But if we come into the synthetic data, especially when we think about visual data, it's even more interesting. Think about, for example, some of the training they used for training post-detection algorithms. Or another example is, think about, there's a fire in the mine, like some I don't know, gold mine, ore mine, whatever it is. There's a fire inside, and they need to rescue the miners. Like, and you want to send a robot into this, right? Very tough to actually get real world training data for the situation, right? Pretty much impossible. But what you can do is, these days with photorealistic rendering in Unity, Unreal, or NVIDIA with Omniverse and so on, we have physically based rendering. We can simulate these scenarios. We can basically recreate kind of a digital twin of that environment, and then run endless variations with different shading, different colors, whatever. We can have different styles of fog and smoke in the mind and what have you. And so then we can use this to train then a physical AI or an embodied intelligence system. And that's also called sim to real, right? Where you basically train these systems in a simulation, and then have that trained model and then apply it to the actual physical device. And then it would work also in the real world. But that's what it's all about, synthetic data. And Gartner, for example, is predicting that by 2030, the majority of training data for AI is actually synthetic. And that kind of makes sense. But that also bears the question, my friends, are we entering kind of recursion loop, right? Because, like, are we using other AI models to then generate training data for another AI models? Like, what's going to happen at this point? Is it like a recursion where we lose a little bit of knowledge? I don't know. We'll see.
That is an interesting one, because the thing is, the data generation is based on the data it's grounded on. So on the internet data or whatever you're using. And the thing is, it's also the discussion we had with generating pictures and photos, where it was actually using existing photos which had trademarks on it to generate something new. And then the question is, when is it so new that it is allowed to see as something new? And the same goes for, let's say you want to create some kind of particular data for your digital twin. When is that data actually that new? And the thing is, and that's also a question we wanted to ask, is what are then the ethical considerations and the potential risks associated when using synthetic data? Because that synthetic data is generated on something. It's partly new, but it's partly based on existing grounded data.
Yeah. It definitely raises an interesting question when it comes to intellectual property, for sure. It's like you're saying, it's the same we're seeing with video generation model, image generation model, music, sound generation models. What kind of data are they trained on? Like, surely one music generation model, a pretty popular one, I'm not going to put the name here and to blame them, was accused of actually using commercial music basically from artists, because if you give in a certain prompt, you definitely hear the artist basically, which the model was trained on. And I mean, if you know the kind of style, anyhow. So that's a big ethical question for sure. And of course, artists need to be compensated when their data is being used to train these models. The challenge is, I don't know if the train already left the station, if we're beyond this point right now. If you look at some of the cases from the US, but also in Europe, there's a bunch of cases running with various companies. Just recently this morning, I saw that Reddit sued Anthropic because apparently they used that data for training their model. And so we will see, like courts will decide how this is getting resolved. One thing they already said in the US, I think, is the basically it's if there's let's say let's phrase it differently. If you're generating an image with a model and you give it a prompt like, I don't know, I want to have an image of a Dutch lady wearing, I don't know, typical Dutch clothing, something, and you can imagine what it will generate. But that's no autistic kind of, like, that's nothing that has any big value or meaning in a sense of that you thought about the prompt. But what they said is, if you have a very complex prompt and you thought about it, think about like some of the crazy Midjourney prompts, like with all this stuff.
So your intellectual property becomes your prompt.
Yes, exactly. That's exactly what's happened. And so that's a copyrightable work actually. And but if you have just a very simple thing where there's no really creativity behind it and no value basically that you put into this, well, then it's not copyrightable, right? And it kind of makes sense, I think. Again, it's a matter of the courts have to decide what's especially when we think about artists, how they get compensated. But for sure, it's not okay to leverage and exploit other people's work.
Yeah, I agree.
Yeah. I was just thinking about the huge amount of bias you're introducing if you train only on Reddit.
That's
on the other hand, one of the biggest problems we have within the company I work for is because we're a global company. That means that we have onshore and offshore teams. Our offshore teams sometimes need to access the data from a client. Yeah. As you both know, both working for global companies, that creates a kind of a challenging thing around legal, because as soon as I'm telling something in a Teams call, or I'm sharing data, or they are able to download data, you need to have legal in place to make sure that that is allowed or not. Creating synthetic data would actually be a solution for that, because now suddenly you know that the data is not client specific anymore. It is kind of similar, but it's not the actual data of the client.
Yep.
So that could be an interesting one.
Yeah, that's what you can do with synthetic data and libraries like Faker, for example, that allow you to then kind of obfuscate the data as much as it needed, while still keeping like the kind of relationships and the important information as part of the model, as part of your training data. Sorry, it's it's pretty awesome. It still keeps the correlations basically, and I mean, it's a lot of big questions that we're facing for sure, and another way where we're saying about like how can you make sure it follows, and also how can you make sure it uses the data or it stays in your boundaries basically that you want. It's fine-tuning, right? Like initially we had lots of RAG, basically the RAG pattern pretty much known, right? Retrieval augmented generation. That's a thing a lot of folks have been using, and you can actually use it yourself these days. Basically, if you upload a file to one of these models, that's what they are doing in the end. But the next level is fine-tuning. That's also what we're doing right now massively for a bunch of clients, is like using an existing model, and then you fine-tune that, you teach it kind of behavioral patterns, if you will. And so you judge the output of the model and say that's a good or not so good output, and give that as a feedback. So then it improves the output into a specific direction. And so then you can, for example, take a big foundational model and then fine-tune it for finance, or fine-tune it for healthcare, or whatever sector, or whatever very specific niche you would need. And the cool part is like with the knowledge distillation aspect, you can actually also massively reduce the model if you then do the knowledge distillation, which means you can get a smaller model And especially if we're thinking about regulated markets, where they don't want to deploy everything in the cloud, for example, you can actually have these small models locally running and at a good speed, and good quality, right? That's the enabler, is the fine tuning, basically.
Nice. Yeah.
Yeah, and
So,
yeah, go ahead.
No, go. Finish your
No, I was just saying, and when we come back to the whole synthetic data, like I was saying, we also did one thing where we used actually images generated with Midjourney or or Flux, or some of the latest good models that provide very good photorealistic images. We actually use that to generate training data for safety detection scenario. So if people are wearing safety gear on the job site, and of course you need training data for that. And the training data we did actually generate with these image generation models, and it worked surprisingly very well, actually. And we tested that after the fine tuning. We tested that then with a computer vision model, obviously, that we fine tuned, and we tested it on a public Kaggle data set, which is consisting of real world photos, not synthetic data, but real world photos of people wearing hard hats and what have you. And the detection was close to 90% just with an initial shot in a small training set, right? And so that's a big enabler for sure.
That is an interesting one, since it takes a lot of time to create data to do your vision model on. Yeah.
But in this case, you kind of generated the data almost like manually, or you to figure out a way to generate that data? Are there already like readily available tools or libraries that help you with that?
Well, you vibe code it, you don't need it anymore. Just kidding. I don't know, maybe we use libraries there, but surely we wrote some code I think we generated for each class. One class was safety goggles, another one hot hats, third one I forgot, mask was the third one. For each of those we generated around 200 images or something, and of course that was done with scripting in the end.
Cool. Okay, well, how about we move on to our third topic, because you said the third really interesting development in AI land is embodied intelligence. So why don't you tell us a bit about that? What is it and why is it important?
Absolutely. And so we're now coming from kind of, I would say, a pure digital AI world into an embodied intelligence or physical AI. If you hear NVIDIA, they talk about physical AI, and I think that's a good term for this. So we're putting this, knowledge, this machine intelligence, which I think is a better term than artificial intelligence. So we're putting this machine intelligence into physical devices, and they could have multiple form factors, right? But could be not just, could be simple, fixed camera installations for computer vision. It could be also, of course, robots, drones, what have you, right? Autonomous vehicles, all of that matches into this category. And especially when we think about humanoid robots, that is with synthetic data, that synthetic data is actually the enabler for one of the big humanoid robotics transformation we're seeing right now. Although it might take a little bit longer than most people probably think. There's a little bit of overselling in the humanoid robotics market, I think. But that happens all the time with the hype cycles. But at a certain point, we're going to see like humanoid robots just walking around us. And that's when they have the physical intelligence in these devices. And of course, they need a good world model. They need an understanding of the environment. And that's why we also are working with vision language action models. So I talked about multimodality in the beginning, where we have vision and textual descriptions that go into the model. These are vision language models. And now the next stage is vision language action models. So what you give is, you give an image. So what the robot, let's say the robot is seeing, plus textual instructions, like, I don't know, like, let's take this cup and put it into the dishwasher or whatever it is. And then it gets the input images on of that. And out of the model of a single neural network comes an action the robot needs to perform, which is basically a bunch of instructions for the underlying robotic system. And you then also need to fine tune these models, of course, for your specific robotic hardware, because, it's not generic in the end. But that's what's going to happen when you think about the physical AI aspect and, vision language action models. And that's why we see so much happening in that space right now, because we have these novel AI models, and we have also lots of progress when it comes to mechanical engineering of these robots, the motors and what have you. And so these things are slowly coming together, plus synthetic data that allows us to train these robotic systems in a simulation in the end, and then take this simulation and put it into the reality. And that's what's going to be needed and actually to train these robots, because we cannot have them, train on the real world all the time. That's just not going to work out. But we can have them run a robotics gym at night for, I don't know, 100,000 of days training time, basically. Sorry, not 100,000 of days training. You have maybe 100 days of training or maybe 10 days of training, but they train for a lifetime of multiple robots, basically, right? Does it make sense?
Can you give some? No. It makes sense. What?
Yeah, does that make sense? I don't know if it made sense.
Oh, it
actually.
does. Yeah. Yes. But can you give some examples of like which kind of robots already exist and what they're used for?
Yes, it's a very, very good question. Again, it's we have lots of different robotics systems on the market. One of them is, of course, Bus Dynamics. They have the Atlas robot. We have Figure AI from the US. We have Fourier Intelligence from China. We have Unitree. We actually have a Unitree H1. That's one device we acquired. So it's a humanoid bipedal, meaning it has 2 legs robot. That's actually the only one you can buy commercially is Unitree ones. Like the other ones, like obviously we tried to get our hands on it, but it's not so easy. You have also the Tesla Optimus, you have the Amazon Digits one, and so on, like different humanoid robots that are in the making out there. And big tooling to actually train those to make this happen is definitely NVIDIA's Omniverse. They have Isaac Sim, which you can use inside of that with the Omniverse platform. And I think NVIDIA Omniverse and the Project Root and so on, they have basically I think they're using the Figure AI humanoid robot right now. But again, there's a multitude, and especially we're seeing big push out of China with various different robotic systems, and it's impressive. Like every couple of weeks, we see new stuff. But of course, one of my teams working on that. It's in reality, like when you see the marketing videos, they're all great. But the reality is, you need actually to put much more work into this than they might. Then the marketing videos might look like it. So it's it's still lots of work, and it's not like out of the box things right now.
Yeah.
That's definitely not what we have right now. But I keep on joking. I'm pretty sure we will see humanoid robotics, like let's say in 2030 in a couple of places around the world, while we here in Germany will still send faxes.
Yeah,
I mean, that's like
that's a
5
good
years
point.
from now. Like my real question is like, how long until I can buy one of those robots to like clean my whole house?
Yeah, we all want that, don't we? Like that's what everyone really wants, and I think that is going to be the social acceptance at a certain stage. That's like once they can do this, everyone might want to acquire one, right? It's kind of the next stage of the vacuum robot or whatever.
Yeah.
Like it took a little while, but then lots of people adopted it, and that's probably what's going to happen. But I can tell you, working a little bit with some of these humanoid robotics, and you might actually also want to look up some of the videos when they fail. Like I'm not always feeling very comfortable standing next to those, because if you think they need to balance, right? So when they stand, they need to balance, and sometimes they do this kind of balancing move. It's like a drunk person would do, right? It's just they don't fall down, and basically that can be a little bit scary if it suddenly does that, right? Or moves the arms because it needs to balance itself, right? And then you're standing next to it and get punched into the face, for example, because these motors have quite a good torque, right? They have quite a good torque, and so that's the challenge. I think is the social acceptance. We will probably see them the first in factories, like fully autonomous factories.
It gets me a bit of the feeling of Terminator style, where we're gonna have prime directives. You hurt people, you don't hurt people. So it needs to see if it's in its environment is a person, and then if it can't do anything else, it needs to fall down because it cannot touch the other person.
Yeah, and that's happening. Everyone is working on that because there's awareness that this is, that you need this kind of security layer on top of this. So yes.
I've seen some YouTube videos on robotics where they got that effect and then suddenly started waving their hands, and I've seen some people being hit very well, very hard. And as you said, there's a lot of torque on the engines in there, and it's also all metal. It's like someone is hitting you with a metal pipe.
Yeah. It's like, and these like some of these humanoid robots, like the one we have, it's like 70 kilograms or something. Right?
Yeah.
So it's quite, yes, it's quite kind of the impact you can get. Yes. So, but hey, that's the fun. They call it bleeding edge for a reason, because you're bleeding on the edge.
But like those kinds of robots, like is there also work into like emotional artificial intelligence?
Yeah. We're also quite invested in that with affective computing. Not effective, but affective computing. That's the term you want to look up if you want to dive deeper into this. But basically, it's all about sensing human emotions and then providing a good emotional response and synthesizing in the end a good emotional response. That's what we're doing with our digital humans. But we also applied the same technology backend to one of our humanoid social robots, Ameca. This cool robot head where it has 42 servo motors in the face, can do very well facial expressions. And so and we use it also with our digital humans, which we now turned into our digital paintings. I'm actually going to probably publish a video from our recent event on LinkedIn or so today. Let's see. But it's with a digital painting. So basically, we made Harry Potter science fiction reality, where you have a really cool looking, that really looks like a painting. You don't see that as a screen. Like the secret is a little bit, we kind of coated the surface really nicely, so it doesn't look like screen. It really looks like an oil painting. And then suddenly the painting talks to you, and you can do this interactively. So you have a conversation with a kind of a digital human behind that. And we also have this kind of affective computing model where it's actually a multi-agent system where we're using different emotions, and each of them is an agent, and they all say, okay, like I hear the voice from the user, I hear what they're saying, I hear how they're saying this, I see their expressions, and okay, they might not feel too well, and so I got to react a little bit more empathetically, and then the system will then basically provide not only the textual output, which is more empathetic. I mean, language models can do this easily today, but also the correct tonality, right? That the tone, the audio sounds well for you, and also the facial expression of the animated character actually matches this. And we were lucky. That's actually when I saw Saskia at SIGGRAPH. That's what we showed there basically at SIGGRAPH when NVIDIA invited us to do this.
Nice.
Yeah, that was really cool. Yeah, I just had this vision of this movie Up. No, that's not Up. What's that movie? The Disney movie with all the little emotion people that are in the person's head. Inside Out. Yeah. That's a bit what it sounds like, with all those little agents. Like one is sadness, one is anger.
That's actually how we modeled it, kind of. And the fun thing is, that's what I sometimes love. You think about, that's a kids movie or something, but actually, the Inside Out movie is based on a scientific model from Paul Ekman, a psychologist. And he describes all these different emotions, basically, and that we're using the same kind of approach right there. But there's even further models with 48 emotions. Like, can you imagine what is 48 emotions? Like, I don't even.
We actually watched it together.
I know I only know anger and smiling. That's my only two emotions. No, kidding. But it's like it's really based on psychological models in the end.
Yeah. I remember that, like from my student days. Like there were 5 back then. 5 of those
that's
emotions.
a lot more now.
It's growing. I mean, it's not the Paul Ekman model. There's another researcher that has another model, and I think Hume AI, if you know that service, they're using a different model where you have all these different emotions. It's pretty amazing.
It's really so interesting. So much is happening, René. Like I think we need to round up soon, but like if you look into the future, what's the next big thing that's going to happen that we have to look out for? Apart from humanoid robots and emotional robots.
Yeah, that's a big question. I mean, what's definitely is going to happen, especially for our technical audience, I think it's a big shift in how we develop systems, how we build systems, and we need to give a little bit of autonomy to these agentic systems, but also need to learn how to use those and leverage it. And at the same time, we also need to balance, especially some of the expectations that are being set out there, basically saying, I don't need all the developers anymore. I can just use my multi-agent system, right? And then at a certain point, they will probably realize, well, that's actually not going to help fully. I still need people that can actually understand it. So I think the big shift is definitely the big challenge is also a societal aspect and the big shift in the mindset. And like I said, when I talk with students or young developers that embrace already these AI assisted coding, they have a whole different approach than we would do as a kind of veterans, if you will, developer veterans, because we learned it, right? It's muscle memory, and so you got to unwire a little bit. But yeah, that's why the biggest thing is, I think the biggest change is the whole how this will transform society in itself. Like that will be massive. And computer
Let's
use
see how
agents.
the future is gonna be.
Yeah. Computer use agents. That's probably another thing I didn't mention too intensely, but that's probably two most important things that are going to have the biggest impact is humanoid robots. Think about workforce and factory, right? That's massive. And the second is for the white collar worker, rather. The office worker, for example, is a computer use agent, right? You can use an agent that sees your computer screen and can also then operate applications on behalf of you. So think about your crazy ERP or CRM systems that are very hard to actually use, and you need to be trained on that for weeks actually to actually properly use it. Well, you can automate that now as well with computer use agents, right? But we got to make sure they run in a secure, constrained environment, because otherwise they're just going bonkers and doing wrong things. But yeah, I think biggest change is societal mindset.
Yeah, I agree.
Okay, Renee, thank you for so much information you gave us. I really liked this podcast. Thanks.
Thanks for having me. Thanks for having
Thank
me.
you so much.
Also thanks for my side. I always love to chat with the both of you. So thanks for having me, and I hope that it was also useful for your audience. Thank you.
Okay, thank you.
Thank you very much.
Okay. Thank
Bye
you.
bye.
Bye bye.
Bye bye.